Hey guys, it's Vince. Today in this video, we'll be taking a look at yet another CNC fail video where an influencer is discussing how he attempted to ground a Shapico CNC chassis. Now, many of you are dealing with these type of chassis, whether it's a Shapico or another brand, in terms of dealing with isolated components, not allowing full conduction all the way through. We'll jump right in and we'll cover the basics of what you need to know to do it right.
Let's talk about grounding your Shapico CNC machine. This isn't something everybody should do.
Okay guys, we just heard the influencer explain that grounding a CNC chassis may not be required for all end users. And that's simply a line of BS. The fact of the matter is that in best practice, all CNC chassis should be grounded properly to dissipate EMI and of course be safe. Most vendors that sell these machines never really disclose that to their end users in great detail because they themselves simply do not understand it, and that's fact. Okay, what we have is a line of distributors who, once again, fabricate the chassis. They usually understand the electronics enough to get motion, and then they sell these units self-proclaiming that they designed a robot, and they always are missing critical details, and grounding is always the first usually on that list. So let me show you what I did so you can alleviate some of the BS. I just typed into Google in an open search, grounding a CNC chassis is mandatory. And you can see here it says, yes, grounding a CNC chassis is mandatory. It then gives us a list of bullet points, starting with the ground rod, earth ground, shielded electrical cables, which I find very interesting, and you'll see that as we go through and really analyze this video. But overall, what I want to point out, and this is something seldom discussed, I've never seen it personally discussed, is that you have to understand when using the internet how to use Google or any other search resource and decipher what terminology you're going to put in or what phrase so you can get a consistent answer. Many times end users will type in something inside of Google and say, well, that's the answer because that's what came up first. They don't actually residually go in and retype another phrase or category to see if they're going to get a line of one word that's most important, which is consistency. Consistency will delegate more truth than doing a one-time search. And if you see here, grounding a CNC chassis is mandatory. If I take out is here, and I put in is here, is grounding a CNC chassis mandatory, and I click enter, you can see here, grounding a CNC plasma system is a necessary precaution. So it does come up with similar results, but they're not exactly the same. And that is where, once again, you have to be able to decipher how to use Google and other resources to understand that due diligence process. If you're not getting the correct information, you will notice that a lot of confusion is formed. And the other factor is, even if you are getting a lot of information, which on this topic there's massive amounts and you don't know what's true and what isn't, that's where it's important to have a resource. And once again, that's where consultations come into play with actual professionals that understand this process. And once again, that is why I offer consultations. If you find that you're getting hit with a lot of information overload, the best thing to do is eat the elephant one bite at a time. We already see here that grounding a CNC plasma system is a necessary precaution. Well, we should all know that a CNC plasma system is just a CNC robot that uses a plasma cutter. So realistically, if it works for that robot, it should, in theory, work that principle with all robots because they're all the same. It doesn't matter what cutter you're using. Once again, pretty much all the industrial CNC plasma systems require an earth ground. I'll rest assured to all of you, every industrial CNC plasma system require earth grounds. The big thing here is understanding what is mandatory and understanding how to go back and search everything. You can see I just used the back button and I pull back up my first original phrase, which is grounding a CNC chassis is mandatory. And once again, we're getting more uniform results. So we know that there is some truth to this. As a matter of fact, it goes in great length and great detail once again using bullet points in this particular format and shows us exactly what we need to know.
There are a range of factors. Materials such as plastics, cutting in a low humidity environment, and the use of dust extraction can all build up static electricity on and around the machine.
Okay, guys, so what he's saying is absolutely correct. There are a lot of variables that will contribute to creating that static electricity. But the biggest thing we need to look at is the fact that on many of these systems, they're using a wood router, which is not designed for CNC use. I've said this in many previous videos, and these units just spit out huge amounts of electromagnetic interference because, again, they're drawing great amount of amps. The other issue is that your chassis is a conductor because it's metal, and therefore it becomes like a giant antenna. Now, what I always find most interesting with these influencers is they always tend to speak about what they know. And I tell you guys, the spotting the knot is pretty easy because as you see here in this picture, you can see we have cables that are not shielded in any way, shape, or form, and they should be double shielded to mitigate both forms of high and low frequency EMI using mylar foil and tin braided copper. Now it acts as a Faraday cage, once again protecting the leads for corruption of that excess energy. So it's interesting that he'd be so concerned with grounding a CNC chassis, yet leaving non-shielded cables present on the system, which basically yields a chassis that still is highly susceptible to EMI penetration on his signals, which makes the chassis virtually a gamble on whether or not it will actually run stably.
Carbide did a pretty good job with the power supply and the controller on the Shapeoko.
Well, I would definitely have to disagree with that. And once again, I have evidence backing up why I disagree with it. Namely, it's because I've retrofitted now at least 1,000 CNC robots that were using USB and had inherent instability due to the fact that we're dealing with large amounts of grounding issues and large amounts of EMI. Once again, confirmed by Balzis, the lead engineer at CNC Drive, based in Hungary, who is the leading manufacturer in the UC100 category, also known as the most prominent USB motion controller. And you can see exactly what he wrote about using USB and the problems with it inherently being unstable. The other thing I find interesting is that when we look at this, how anyone could ever say that they did a great job when we're looking essentially at a circuit board mounted to a conductor. I mean, that is essentially what we have here, guys. You could see where, once again, the USB port is. You could see that we have integrated stepper drivers on this circuit board, and all they did was mount it on basically the aluminum side frame of the unit itself. The reason we use electronics enclosures is to mitigate electronics from actually being exposed to EMI and also to keep their electronics sound, meaning neat from external sources of the environment they're put in. Now, when we look at this and we know that robots are being used for production, aren't we to assume that there's going to be lots of scarf and debris from what we're machining? This would make absolutely no sense. This is a huge fail on the vendor side, and I'm really shocked any end user would even come close to saying this without doing adequate research, which of course this influencer chose not to do.
The power supply passes mains earth through to the 0 volt of the controller, which is connected to the big heatsink on the back via the mounting bolts, and through that to the left wire rail. Notably though, the screen of the USB connection is isolated. We might think that this would ground the whole machine, but despite being mostly big lumps of metal, there's a couple of problems. First, the powder coating on steel parts is pretty solid, and it's an electrical insulator, so in many places, despite being bolted together, metal parts have no electrical connection.
This is a very common problem, guys, and what he's discussing about powder coating, and he didn't say anodizing, but that's another very common insulator. Any coating you put over metal is going to affect its conductivity. Once again, the ability to pass electricity through it, energy, whatever you want to call it. And the bottom line is, then we create resistance. So when we're trying to ground, we want the lowest points of resistance so electricity can pass through the chassis and dissipate electrical energy. Now, that being said, when you look at any chassis using any type of plastic as far as their linear motion, rails or linear axis, these are where you want to run for the hills. There is no point in today's market, even with resources as high as they are today, that anybody should be utilizing plastic on linear axis. And when I say that, I'm talking about the transmission. Buy yourself a CNC chassis with preferably a ball screw transmission, a rack and pinion, something that is generally used to automate CNC robots. If you notice that they are using plastic anywhere, whether it be your Z-axis, whether it be on your Y-axis, because they'll claim it has two motors, you should be looking at another robot or saving in a format that you can get rid of that and once again implement the proper transmission. All you're doing is reducing the amount of longevity the robot will have. It will definitely not be as precise, and on top of everything else, as he just indicated, you will not have conduction on the remaining components of the chassis. So then again, grounding becomes even more of a daunting task. If you do have the proper ball screw transmission, let's say, or rack and pinion, and we are dealing with all metal componentry, dealing with the chassis connecting in all the right areas with bracketry, even if they're coated, you just remove the coating and you can check and see. It's a very quick process and you do have full conduction. But with plastic wheels or any type of plastic inside the transmission where once again we're limiting our conduction, it makes this process at least 10 times harder for most end users. So once again, on top of the longevity issues, run for the hills, save for a real robot.
Secondly, the V-wheels the machine moves on are plastic, and this isolates parts from each other. What this means is that despite most
Okay guys, you can see here he's using his probe on his multimeter to check for continuity, testing central points of the chassis, and it's really interesting. He's discussing doing this, but he never discusses the proper ohms rating that you should have if you indeed have continuity. There is more to grounding than just testing to see if everything is connected. We need to make sure the resistance is at a proper level, and the lower the number, the better. When you're dealing with CNC robotics, we're looking at a number of 3 or under. You can see he broke down just how bad the continuity is with this 3-dimensional drawing of the chassis.
What are we going to do to fix them? Firstly, we're not going to mess with the grounding or double insulation on the router or the spindle. That's there for safety reasons. Fixing the rest of the ground is pretty easy. We just need to supply ground to the X-axis, the Z carriage if you have the regular router, and the extract hose if you have an extraction boot with an anti-static hose attached.
Okay guys, we're at the point in the video where the influencer has decided to insert his own wiring diagram. And yes, I, like many of you, have found the pattern all too frequent. Whenever we do these CNC fail videos, you can see that all these guys typically do the same thing. They try to take a complex subject, they want to act like they dumbed it down, and unfortunately, like this guy, he's missed the boat because he hasn't even allocated shield drains from his motor cables, yielding all of this grounding that he claims to do useless. First and foremost, this diagram, we can actually make it much simpler. Let's do that now. Okay guys, you can see right here I've really cleaned up the Lincoln Electric PDF's manual image on grounding using a star point ground, and I'm just using the imaging that they have, and I wanted to make this as base level as possible. Let's go over it in detail. First and foremost, all CNC motor shield drains are to be allocated to the CNC electronic enclosure's ground bus. Why is that? Because that will keep them, number one, nice and neat, and will keep your chassis much neater, along with the fact it's all centrally located in the control system for your robot. Now keep in mind, when your electronic enclosure is plugged into your wall outlet, they will all be sharing the same breaker box where that central point of ground is coming from. A star point ground system is a term used to centralize a ground. So you can see the ground bus right here. And again, ground straps is to be used in best practice for all connections with solder ring terminals for mounting. A lot of these guys claim to use crimp connectors, and crimp connectors simply are not reliable sources for connections, and they actually increase resistance. The more you use them, the higher the amount of ohms you'll be working with. So again, these are areas you want to pay attention to. As a matter of fact, if you look at the ground strap here, I double it because I want to make sure that we have as much conductive material as possible, once again, limiting resistance. The more ground strap you use, once again, it's ultra flexible, then it will lower resistance because we have more metal for conductivity transferring any potential energy to this ground bus. And you see all the ring connectors here. Those are where you would connect straps, once again, as you see here, to every central point on your chassis. So you can see right here, we have a point of connection here, a point of connection here. You also have the ground bus mounted on the chassis itself. That will alleviate most of resistance right there, but once again, attaching these other points, excuse me, will reduce it even further. Now coming over to the gantry, and this is interesting. You would come over, naturally run a ground strap to your gantry, and the biggest concern with this ground strap is motion. That's why we use ground strap and we don't use cable, because you are dealing with a large amount of conductive material, and if you use a heavy gauge of cable, it will not be flexible. Ground strap is very flexible. Henceforth, if it goes inside of a cable chain, it's not going to cause any issues. What you will not find is being able to use a heavy gauge of cable. I've had guys ask to use 0 gauge, 1 gauge, and that's just simply not possible. You will have all kinds of problems. Utilizing the proper ground strap guarantees you're getting the most conductive material, bang for your buck, to lower that resistance. All CNC ground points on the chassis must register 3 ohms or under to be considered grounded for CNC use. Use a quality multimeter. Accuracy is a must. Now again, multimeters are all different. A lot of guys want to use, Sentech and other different brands. The choice is yours. I'm just telling you that there's a reason a fluke costs what a fluke does, and there's a reason that a $10 multimeter is $10. If you're registering voltages, it may not matter. If you're trying to take a robot that's $18,000 and we're trying to make sure that it's stable, use your head, use a quality measuring instrument, and make sure these numbers are accurate. Because again, we're only dealing with up to 3 ohms. It's not much. So the better calibration one of these multimeters has, the more you're going to be having peace of mind with knowing that the settings are correct as far as your measurements. Now, the other thing I want to point out, and you can see here, we have another lead coming over to our Z-axis. Now, Z-axes are different on every robot. You may find some that actually are conductive and some are not. A lot of them have spindle mounts which are not conductive. So you'll have to look at that. If you're noticing that your spindle mount is not conductive, checking for continuity, then naturally you'd have to remove some of that material to make it, I'm talking about the coating, to make it conductive with the rest of the chassis. What we're looking at here is, once again, and I'm going to state this very carefully, wherever you put your multimeter's probes on your chassis, and it should be done all over the chassis, I would do at least a 10 to 15 point inspection and make sure you're registering 3 ohms or under. You should do it with the machine off, and then you can also do it with the machine on, pending of course you're not impeding the axis of movement, and see where your measurements are. That is best practice. It's very simple. We have a ground rod right here. We have our ground rod allocated to our breaker box, and then we just running our lead. Now again, here you would be using a ground gauge cable. So the thicker the cable, the better off you are. I have had clients ask if they could use ground strap. You want to stay with codes on that. So that's something where we're getting more into hairy as far as how we're actually wiring it for our shop or for our home breakers. So that's a different area. Every state is different. From the chassis and the ground rod, you will use ground strap. That's best practice. The terminals for the ground strap must be soldered. Once again, the terminals for the ground straps must be soldered. That's best practice. Once that's done, and these leads are applied, once again, you can see all the ring terminals. That's so you can apply the leads. Right here is the ground bus, and you just attach the straps. The main thing is that no strap will impede motion on your chassis. Once that's been completed, guys, and you've taken the measurements of your chassis to register 3 ohms or under, you are then grounded. If, however, and I hear this a lot, you never took measurements on your chassis but consider it grounded because it's AKA connected to ground, that does not mean that the chassis is grounded. You must refer to the fact it must be at a resistance of 3 ohms or under, or else the chassis for robotics use is not considered to be grounded. So again, looking at this, I think it streamlines everything. We're not getting into crazy resistors. We're not talking about anything ridiculous. As far as ground loops, it's real simple. All we have to do is make sure we have one central point of connection, which right here is the ground rod, and it's going right here connected all the way over to the ground bus, and then the ground bus is going to split all of your grounds, and it does that with the strap. The strap connects to the ground rod here, it comes in and then splits all those connections to once again feed leads to your table, so everything is utilizing one central point of ground. If you're doing connections only at one central point of ground and there's only one lead coming from the ground rod to your chassis, you are golden. You don't have to worry about a ground loop. Ground loops happen when you connect more than one lead going to ground. So real simple, as long as you don't have another lead coming back to another ground somewhere else in a loop, then you're basically fine. I mean, I hear that term come up a lot and guys get kind of hung up on it. The big thing here is that you have one central point of ground, which is the bus, and then of course it comes to the ground rod. And once again, if we look at our CNC electronics enclosure, the CNC motor shield drains from their motor cables should all be allocated to the ground bus mounted inside the electronics enclosure. And you will notice that once you plug that cable in to power your electronics enclosure for your CNC electronics, that it will all be going to the same central point of ground in your home or your shop, which would be the breaker box. So everything connects there, guys. There's no funny business. There's no double connections. It's very, very simple. The main thing is that we keep diagrams the way they should be, and we cover all the details. Once again, if you're not using double shielded cables for every accessory that carries signals, that means switches, motors, anything, you are going to find that grounding your chassis is all but useless. Think about what I just said. That means everything this guy just said in all this video, on top of doing the diagrams and everything else, if you're not using double shielded motor cables, then essentially you've done nothing, because now, yes, your chassis may be grounded, but if the motor cables have no shielding on them, they can have signal penetration, and therefore that EMI can corrupt those signals, and he wouldn't know if his chassis is grounded or anything else because he never measured any ohms rating on the chassis. And this is where we get into that cumulative loop of misinformation where guys think, hey, I've grounded the chassis, everything is good. Unfortunately, that's not the case. So check out this diagram, go over it carefully, look at your system. It's very simple. Another question I want to cover real quick is ground rod depth should be 3 to 5 feet, and I'm talking about depth of insertion into Mother Earth. Okay. This is not an easy process. It's not a real simple process in labor form, because a lot of guys think, oh, I can go do this. You have to insert this close to the machine, preferably, I would say optimally within 10 feet or under is really optimal. I've had some guys in their shop, if they're doing larger machines, they'll put the ground rod right in the shop, especially if it's a plasma cutter. So these are things to keep in mind. If you're dealing with plasma CNC robotics, the closer that ground rod is to your chassis, the better off you are. If you have to go through concrete, guys will do it. So you think about what I'm telling you at the level we're talking about, and then everything makes sense. Now, this ground bus bar is very large. It's not going to be optimal for smaller chassis. If you have a smaller chassis, I have other solutions for that are very similar to this. The main thing is that we're always using a single point of ground, which would be right here on this ground strap, going to a ground rod.
I'm using simple crimp rings on the wires here because they're an easy, effective and fairly reliable way of bolting the wires down to get a good electrical contact.
Okay guys, once again we see an influencer doing what they all do, and that is that they take the path of least resistance. Don't be that guy. If you're planning on using crimp connectors with precision CNC electronics, you are doomed at one point or another to failure, because you are assuming that the crimp tool is assembled with precision and is applying the exact same pressure to every connector. And the problem with crimp connectors are none of them are manufactured to exact spec. They're manufactured in bulk. So if you get a bad one, or you use a crimp tool over time, because many guys have crimp tools that are older, they're not assembled correctly in the sense that they're going to have that level of precision consistency, you're going to have potentially conductors split. You're going to have too much pressure on some conductors, not enough on others. I've seen them actually come off as far as crimp connectors sliding off the actual cable. I've had guys split cables. It is a mess. When you're dealing with precision electronics, you always deal with soldering, and that means solder, flux, and technique. If you don't have those three in combination, yes, you may have problems with soldering, but if you do have those three, and believe you me, you apply Kester 186 RMA flux and Kester number 44 solder, and you use the appropriate heat, you will notice a weld like you would not believe. Welding is always going to be a more sufficient way to deal with general assembly on precision electronics. Hands down. It's that way with your cell phone. It's that way with every spindle connector that comes from overseas. This is not myth. This is fact. And whether or not you want to do it or take on to, accounting that labor into when you're actually working on your system, this is something you need to understand. If you want a forever connection, soldering is the way to go.
Until you can get a clean connection. The carrier plate for the Z-limit switch, some other bolts, and the belt pulleys were all also electrically isolated.
If you guys notice you do not have conductivity on your Z-axis, which is very common, in any location, as you can see him going through these bolts really quickly, the thing you want to do is write down or mark what areas on this axis have no conductivity. This way you know where you have to remove material, once again as far as the coating, which we can see applied here, which is on many systems, and this way you will get the conductivity you want to the remaining portion of the chassis. And once again, as he's going through and doing these connection checks, you want to also make sure that when you do get a reading of conductivity, that the ohms rating is 3 or under to be considered grounded. Okay guys, now all we're going to see him do is naturally take a probe and make contact on different points of the CNC chassis to make sure he has continuity. And I'm going to emphasize that you guys should do this both with the machine off and also with it on, making sure that all of your continuity connections are where they should be at registering 3 or under as far as your ohms rating. And in this way your machine will be considered grounded. Once again, he's using crimp connections, which is a definitive no-no. Make sure all connections are soldered. Okay, guys, that wraps up another video. And one more brief point before I go. Document all of your readings from your grounding points on your system. Now, why do I say that? And to do it with a cell phone with an actual video, because in the event you ever notice the machine act funny or something you can't figure out, you can just go back to that video and check what those measurements were when you actually grounded the system initially, and therefore see if everything is still up to par with what you took the first time. If they're not, you might want to then look into an issue that could be causing that, whether it be loose connections, all kinds of crazy things happen. Do not take stability and grounding for granted. Trust me, check everything. Once again, I hope the video has helped, and I hope you guys now have, once again, more knowledge to look out for when we see these influencers do videos. And I cannot emphasize enough, guys, make sure you worry about grounding when every other detail of the system has been completed, namely using double shielded motor cables and making sure that they are properly grounded as well with their shield drains. Otherwise, doing all the grounding in the world is useless, just like he's using a USB motion controller, which dealing with grounding on top of that, once again, makes everything all but useless. So thank you all for your support. Take care.